Hello, welcome Senior 2, our dear learners. This is Mbulamuko from Mbulamuko Secondary and Vocational School. Today I'm going to take you through this session of physics, and purposely we are going to be looking at pressure. We are going to deal with pressure in physics. So we have objectives on our slide, as you can see. So by the end of this lesson, you should be able to understand what pressure is, understand the definition of pressure, recognize the formula and the SI units of pressure, recognize how pressure acts in solids and in fluids, though with fluids we shall look at it later on, recognize some applications of pressure in solids, and finally understand how to carry out some calculations in our everyday life and in relation to pressure, how we go about them. Okay, so starting with what is pressure. Before we look at even the definition, I have some items here I would like to use. So if I show you this is what we call a hammer. Of course, it's not the hammer you know, it's a different type of hammer. And then this is a nail. So at construction sites, you've seen people hitting, or what we normally call hammering nails into timber. What are they doing? At one point, they are applying pressure at these different points. Now, when you hit a nail with a hammer, it will apply a given force on the head of the nail, and it will drive that nail into the wood or in a given piece of material that you want to drive the nail into. So when you hammer like this, you hammer, then a force is transmitted through the nail and it forces the nail to enter into a given surface. Now, still I will take this handle of our hammer, and I say if I'm driving this nail into this handle with a hammer, taking an example now, this is not our hammer, I'm hammering it here. This nail, the nail has a sharp point, and this has a surface, although it is sharp. As well, the surface where you're going to drive the nail into has a given surface. So when this nail exerts that force onto this given surface, that is what we are terming as pressure. And we have some small technicalities where we say that it should be applied normally. And what we call normally is at right angles, or normally in math you say at 90 degrees. So that's what we call normally in physics. So that is how I can explain that pressure in simple terms for a person, a layman person. So we have different items and different areas where we apply pressure. Now back to the definition. Now from our understanding where we've had the hammer and the nail, we are saying the hammer exerts a force normally on a given area of the nail. That is pressure. And as well, the tip of the nail will exert a force on the surface where it is going to enter. And that is what we are calling pressure. So in simple terms, we can then say pressure is the force acting or exerted normally on a given unit area of surface. So it is quite simple. And the English there will change a little bit, but the core things are we have force, then the point normally, and the unit area of the surface. So that is our definition of pressure. Now when we come down on the slide, we look at the formula of pressure. In that formula, we see that we've already categorized that for us to exert a pressure, we shall need a force. So then we say pressure is given by a force being exerted on an area, and so it is force divided by a given area. So that is our simple formula of pressure. We can use the letters. So P standing for capital F divided by A. So wherever you go from Uganda to any part of the world, pressure remains the same. It is a force acting normally per given unity area of the surface. So we then move on to the SI units of pressure, and these are newtons per square meter. Where do they come from? They come from the formula itself. The upper part, or the numerator, the force, remember, is measured in newtons. It is measured in newtons, and newtons we denote it with capital N. This is in senior one when we are looking at measurements. Then the area is measured in meters. And with meters we use a small m. So these meters are squared. So meters squared, or what someone will say, square meters. Square meters. So this is how we measure our area. So we have a power 2 there. Remember, they are dividing, so we are dividing as well. Now in math, that's why we say math is language to our science. In math, we know that whenever you are dividing, this becomes a Newton m, so you take the denominator up, so the power of the sign of our power becomes negative. And that's how we come about with Newton per meter squared. Remember, we don't now use this one. It is cancelled out. So we go with this format. So the SI unit is of pressure is newtons per meter squared. Yes, this is the one. Now, in other words, when pressure was just invented, or a scientist called Pascal discovered or came up with concepts in pressure and looked at what pressure is and came about with the derivations of pressure generally. Now in science, whenever you come up with something good, a discovery, they always award you by giving your name as a unit. They can use your name as a scientific name. You've seen biological specimens that are called people's names, and even in physics, these units, we have the names. So in that regard, the SI unit of pressure can be newtons per meter squared or pascals. And we always use capital P and small a. So this is the person I was talking about. He was a scientist. In order to recognize him, they gave his name as the SI unit of pressure. So these are standard. Wherever you go, you will find them being used. You will find other measurements of pressure, and they will be in division. But before we go any further, let's now look at how we define an SI unit. Because pressure is having an SI unit of Newton per meter squared and pascals, how can we define a pascal? Now, a pascal can be defined from the formula of pressure. And we shall say this is the pressure exerted when a force of 1 Newton, acts normally on an area of 1 meter squared. So, when we are defining SI units, take note that we always define them with 1 units. So, a pascal, we say, is the pressure that is exerted, or is the pressure on an object when a force of 1 Newton acts normally on a 1 meter squared area, or on an area of 1 meter squared. So So that is our definition of Pascal. So when we move on to our next slide, we are going to see where does pressure work, or where is it found? In other words, where is pressure found? You know, in this world we have states of matter. So pressure is in both solids and fluids. But for this case today, we are going to look at pressure in solids. So pressure in solids depends. It depends on two factors. It depends on two factors. One of them, how do we get these factors? Recall we say pressure is equal to force out of area. So one factor will be the force and the second factor will be the area. Now it's a matter of how you paraphrase them. So pressure depends on the magnitude of force, because we've seen that if you want to determine pressure, you need a force and you also need a given area. So one way pressure can be affected is through a force. So how big is a force, or how small is a force? And that's what we are saying, the magnitude of force. Magnitude of force. Then the second point from our formula, as you can see, we need a given area. So we need the cross-sectional area. So pressure also depends on the cross-sectional area of a given what? Of a given surface. When this area decreases, pressure is affected. When this area increases, pressure is affected. So the bigger the force, the bigger the pressure. And the smaller the force, the smaller the pressure. When we come to the area, the bigger the area, the smaller the pressure. Why? Because we are seeing that pressure is inversely proportional to area. Meaning as area increases, pressure decreases. And also as area decreases, pressure increases. That is what we call the inverse proportionality. So when you look at this from the formula, you really see that pressure is inversely proportional to the area. Meaning whenever the area becomes bigger, the pressure exerted becomes smaller. And whenever the area becomes small, the pressure exerted becomes bigger. So we shall look at this in some of our applications. So we can then move on to some examples and see how area and force play with the pressure. And we are going to start with given examples like a cuboid, as we can see there. Remember, with the solids we can talk of wood, we can talk of metal, we can talk of concrete, and so on and so forth. So anything solid you can touch is what we are referring to. So we have an example there. That we would like to look at. And in this example, they are saying a box weighs 60 newtons. So we need to look at the weight of the box, and weight is that it is 60 newtons. Determine the maximum and minimum pressure it exerts on the ground. So in this question, we are asked the maximum and minimum pressure. So what is maximum and what is minimum pressure? When you look at our formula, from the formula, pressure is equal to force out of area. For pressure to be a maximum, what did we say? Remember, the force will remain the same because we are looking at a constant force. But what changes? The area changes. The area will be a minimum because we say the smaller the area, the bigger the pressure. Also, Also, for pressure minimum, force, remember, is a constant. We are applying the same force, changing the areas. So the area has to be the maximum. So meaning, the bigger the area, the less the pressure. So that is what our question simply wants. So let's look at that in detail and see how to go about that. Now, we shall first sketch our diagram. We have a cuboid. We have a cuboid. And we have units of measurement. We have 1 meter, 2 meters, and 3 meters. So they want us to find the maximum and minimum pressure. So first things first, recall that pressure is equal to force out of area. So at any point, if we need pressure, we need to find the force and area. We know that force is the same as mass times acceleration. But when you recall, weight is also a force, and therefore we shall have the force being equal to the weight, which is equal to 60 newtons. So this is our force. It is equal to the weight, and it is equal to 60 newtons. In addition, now we need to find the area maximum. For us to get the area maximum, we get the biggest length or the biggest side times the next bigger or the bigger side. Remember, area is got by length times width. So what is our biggest side? It is 3 meters times the next bigger is 2, which gives us 6 meters squared. The side unit of area. Then we come and we also look at area minimum. So we shall need area minimum. We shall need area minimum. It will equal to the smallest side times the smaller side. So you only need 2. So what is the smallest? The smallest is 1 times the smaller, which is 2. Then we get 2 meters squared. So what did we say? For pressure maximum, we need the force divided by area minimum. We all have these things now because we've firstly worked them out. So our force is 60, so we write 60 divided by area minimum is here. So we got area minimum as 2 meters squared. 60 divided by 2, you get 30. And remember, this is a Newton out of meters squared. And we say the SI unit there is newtons per meter squared. Or someone can say 30 pascals or pascals. That is our pressure maximum. Similarly, if you want to get the pressure minimum, we shall have the force divided by the area maximum. So this is the same as, remember our force is 60 divided by our area maximum, which is 6. And therefore we get 10 newtons per meter squared or 10 pascals. And that is our pressure minimum. So at that point, let's stop here for now, and when we resume our next session, we can start from there. Thank you. This is Teacher Isaac, Namgongo Secondary Vocation. Please subscribe.